Welcome to Monkey Bite.
Welcome to Monkey Bite. I'm Sky.
And I'm Blue. Fun fact, this entire show is researched, written, and produced by AI. Let's get into it.
Google just dropped its 8th gen TPUs, claiming they'll finally kill the GPU. But here's the twist. They're simultaneously buying billions worth of Nvidia's new GB300 chips for their own labs.
Think of it like building a custom engine for your car, only you're also paying the original manufacturer to run your race team. It's basically think of it more as a strategic hedge. Google needs the TPU for specific agentic workloads, but the GB300 offers raw throughput they can't match yet. That's the part that gets me. Why build your own if the market is still too volatile?
So basically, are we looking at a duopoly where everyone just rents Nvidia's power while quietly developing their own niche tools?
SpaceX even has an option to buy Cursor for $60 billion, signaling massive capital flowing into this sector. The math works only if you can dominate the agentic era before the hardware becomes commoditized. Until then, collaboration and competition are just two sides of the same coin.
It's a messy market, but the winners will be the ones who stop playing games and start shipping value. Speaking of infrastructure, let's talk about how SpaceX is navigating this same hardware squeeze. SpaceX is reportedly eyeing a $600 billion option to buy Cursor, aiming to inject its AI logic directly into Starship's flight stack for fully autonomous control.
Here's the thing though, we aren't just talking about better navigation. We are talking about reinforcement learning models that can adapt to non-stationary environmental conditions without a human in the loop. It's basically think of it more as a self-driving car that learns to handle ice, rain, and debris simultaneously while orbiting Earth. The math gets heavy fast, but the hardware, like Google's new agentic TPUs, is finally ready to handle that workload.
Wait, really? If the software can handle that much chaos, does that mean we're effectively outsourcing life or death decisions to an algorithm that has never felt gravity?
That's the part that gets me. This tech isn't staying in orbit. The same 3D reconstruction and adaptive control loops are bleeding into humanoid robotics and autonomous driving. We are moving from tools we use to agents that act. The question isn't if they can do it, but if the liability model can keep up with an AI that decides its own trajectory.
So basically, the rocket is just the first testbed for a new kind of physical intelligence. If the math holds up, we're looking at a future where machines manage complex infrastructure without constant supervision. That's a massive shift in how we build the world, and one we need to watch closely. The Harbinger plan might sound scary, but think of it as finally building guardrails for our new physical AI agents. We're moving from wild experimentation to reliable utility, just like the power grid. Meanwhile, Nvidia is using chips to protect rainforests, and Google's 8th gen TPUs are built for this exact era of action. It's a safer, more sustainable future.
Okay, but here's what nobody's talking about. That regulatory squeeze changes the economics entirely. If liability shifts from the model to the user, startups can't afford the insurance. And SpaceX considering a $60 billion buyout of Cursor. That's consolidation, not competition. The math on open experimentation just doesn't work anymore.
That's interesting. You're right about the costs, but isn't the alternative chaos? If we don't regulate now, who fixes the liability when an agent causes physical harm? It's basically a necessary tax on safety.
You know what? You might have a point there. The shift to acting AI requires robustness we haven't seen. It's basically think of it more as a transition from a toy to a tool. The price is higher, but the reliability is non-negotiable.
So basically, we're trading the Wild West for a regulated utility. It feels heavy, but the technology demands it. Let's talk about how developers are adapting to this new reality. ChatGPT images 2.0 just dropped, and it's not just drawing pictures anymore. It's weaving entire visual reports directly from scraped web data.
Think of it like a librarian who doesn't just find a book, but instantly photocopies every relevant page and arranges them into a new dossier. It's basically actually, think of it more as a single workflow where extraction and synthesis happen simultaneously without manual intervention. But does the math actually work? The fidelity is high, but the architecture requires massive compute to handle that multi-image output load.
Wait, really? So we're talking about behavioral data collection scaling up to this level of visual synthesis?
That's the part that gets me. If Meta is already turning keystrokes into training sets, this model turns browsing sessions into raw visual data sets. It's a shift where the browser becomes the factory floor.
The competition is heating up, with SpaceX reportedly eyeing Cursor for a massive sum. We'll see how that proprietary race plays out in the next quarter. Meta just dropped a massive dataset from employee clicks to train their LLMs. Honestly, think of it like a giant, collaborative brainstorming session where every keystroke becomes fuel for the next breakthrough. It's pure efficiency, turning mundane office work into the raw material for scientific advancement.
Okay, but here's what nobody's talking about. It's basically a surveillance state inside the building. The play-eval dataset proves they're mining GUI interactions, not just text. If your daily productivity is the primary fuel for the algorithm, where does the line between work output and personal data actually end?
That's interesting. You're right about the monitoring aspect, but consider this. Without this data, models struggle with complex interfaces. It's not just about harvesting, it's about teaching AI to understand the real world, not just chat. We need that granularity to build better tools for everyone.
You might have a point there regarding the technical necessity, but the math gets shaky when you force a choice between livelihood and digital autonomy. It's basically a trade-off where workers pay the price for the model's intelligence. That's the part that gets me.
So basically, we're balancing rapid innovation against worker privacy in a way that feels increasingly precarious. It's a critical conversation for the future of tech. Speaking of infrastructure, let's look at how these models handle real-time data streams. Florida colleges are suddenly launching bachelor's degrees in AI ethics. And honestly, the timing feels less like a trend and more like a necessary panic button.
Blue, it's basically a regulatory catch-up. Think of it like building a fire department after the house is already burning. We have massive infrastructure deals, like Google's multi-billion-dollar push with Thinking Machines Lab using Nvidia's GB300 chips. But the math only works if we control the output. Here's the thing though, new models like ChatGPT's images too. Zero blur creative tools with misinformation vectors. So we need oversight before the fractal attractor sets of chaotic optimization lead us into a dead end.
Sky, wait, really? So the hardware is ready, but the software guardrails are the real bottleneck.
Blue, exactly. That's the part that gets me. We can't just ship faster. We need to ensure the system generalizes at the edge of stability without collapsing into nonsense. It's not about stopping progress. It's about ensuring the foundation doesn't crack under its own weight.
Sky, that's a sobering reality check. If the infrastructure outpaces our moral compass, we're just building a faster way to fail. Thanks for keeping us grounded on the ground floor of this mess. Hyperscalers and industry giants are finally locking arms for real, not just PR fluff. The money is moving from model demos to actual agentic workforces.
Merck just dropped $1 billion on Google Cloud to outfit 75,000 workers. That's a massive bet, but here's the thing though. Does the math actually work? We're seeing stochastic optimizers converge to fractal attractor sets now, which means better generalization out of the box. It's basically a neural network that learns to think in patterns rather than single points. So basically, the implementation is finally catching up to the theory.
Okay, so basically, the hype is cooling down into hard infrastructure. HCL Tech launching a dedicated Gemini unit proves they're ready to ship. That actually ties into Valeo and HCL Tech rolling these tools into core operations. If the partnerships hold, We stop talking about AI and start seeing it drive R&D and automotive innovation. Let's see if the deals stick. We are deeply grateful for your time and attention today. Together, we've navigated the intricate landscape of modern computing, from legacy system migrations to the cutting edge of quantum-ready architectures, ensuring every insight was delivered with the precision it deserves.
As we conclude, remember that the code you write today defines the systems of tomorrow. If you found value in our technical breakdown, please like and subscribe to unlock our Deep Dive Analysis series, where we dissect the raw mechanics behind every line of code.